Hey guys, Mr. Martin back again with today's lesson on proofs. This is going to be part one of our lesson on proofs because today we're going to tackle just algebraic proofs. In other words, we're going to solve some equations using algebra and we're going to prove that our solution is correct. I'll tell you more about what I mean by proving our solution is correct in just a minute. But before we get going, let's talk about what is a proof. A proof is a logical argument using deductive reasoning that shows a statement is true. Now, you remember from our discussion about deductive versus inductive reasoning, we are not going to use things like opinion. We are not going to use things like feeling. I feel this is true. We're not going to use things like what I think is true. Okay? We're not going to use anything other than fact. Again, the key point here is we're using deductive reasoning. So all of these things are a big no-no. Okay? All right. There's lots of kinds of proofs. And in almost every proof that I know of, we always use things like postulates, properties, definitions, and theorems. We don't use, like I said before, any opinions, feelings, assumptions, things that we think are true. Okay? I'm going to do what's called a two-column proof. The two-column proof is a proof that has numbered statements and corresponding reasons that shows an argument in a logical order. Okay, so there's going to be a statement and a reason, a statement and a reason, a statement and a reason. You must give a reason for every statement that you make. All right, let's go at it. Here's the first one we're going to do. We're going to prove what the value of x is if we know that 2x plus 5 equals 20 minus 3x. So what we have so far is we have the hypothesis. So we say if 2x plus 5 equals 20 minus 3x, then x equals blank. Right? We're going to prove what goes in that blank. Okay? We're looking for the conclusion that we can make because of the known information. We know 2x plus 5 equals 20 minus 3x. We're going to deduce from that what the value of x must be. All right, here we go. So statement one, the first statement we're always going to make, number one, is the given information. 2x plus 5 equals 20 minus 3x. Okay? And our justification for that is going to be that that was given. Nothing fancy there. We knew that was true because the problem started out by giving us that information. Okay? Next step. We're going to go ahead and add 3x to both sides. We know from Algebra 1 days that as long as we add the same thing to both sides, it's going to be still balanced or true. Okay? The reason we give for that is the addition property of equality. Okay, we just talked about properties in the last video, and you guys know about the addition property of equality. Okay, so now we know, obviously, we can clean up this equation and make a new equation that reads 5x plus 5 equals 20. Because, of course, we all remember from Algebra 1 that any number plus its opposite is 0. Okay? And what we can write for a justification or a reason for that is that we just combined like terms, we simply added, we simplified the left and the right side. Really, there's a lot of different reasons you can put right here, but I'm just going to use the word simplify. Because that's really what we did. We simplified the left and the right side. Okay? All right, let's do another statement. Okay, I think the next obvious step is we're going to go ahead and subtract 5 from both sides. And how do we know that we can subtract 5 from both sides and keep the equal sign in between? That, of course, is the subtraction property of equality. All of those properties of equality basically say whatever we do to one side, we have to do to the other in order to preserve that equality. Next step. Let's go ahead and, like we did on step 3, let's go ahead and combine our like terms. Again, we know that any number plus its opposite is 0. So we're going to say 5x must equal 15. Again, our reason is going to be that we simplified. Okay? You can put combined like terms there. You can put simple addition. Okay? Last step. We know that we can divide both sides by 5, right? And we can make a new statement that x equals 3 thanks to the division property of equality. Okay? So we've reached the end. We now know our conclusion. We know now that x must be 3. And we have a proof. Every statement has a reason. Okay, so let's show the 2 columns. Okay, there's your 2 columns. Over here in the left column, we have all of our statements. Over here on the right column, we have all of our reasons. That, guys, is why we call it a 2-column proof. No mystery there. A 2-column proof must have 2 columns in it. All right, let's try another one. Hey, starting out now with something that has parentheses. Okay, and when I'm reading a problem and I see parentheses, there's already one property that I'm thinking of, but I'm jumping ahead of myself because I know the first thing that I need to write down is the statement that they gave us. Okay? Okay, so the statement they gave us is that negative 4 times 11x plus 2 equals 80. Okay? How do we know this? We know this because they told us. It was given. That was the hypothesis of our original statement, right? Okay, so let's go ahead and, like I said, let's go ahead and distribute and get a new equation. The new equation will be negative 44 x minus 8 equals 80. And how do you know that that's true? We know that's true from the distributive property. Notice we don't put there my 7th grade teacher said. Okay, we have to give a mathematical reason why we know that new statement is true. Okay? Let's go ahead and add 8 to both sides. Now, there's a lot of discussion about whether you need to show the add 8 step or you can go ahead and just write the new statement. I'd like you to go ahead and show it because we know this next step is true because of the addition property. Okay? So let's just go ahead and write that this is the, and I'm going to start abbreviating because I know you guys as well as I do start to get tired of writing out all these big words. So how about the add prop of equality? Okay? That stands for the addition property of equality. Okay? So now let's go ahead and simplify that and make a new equation. We get obviously that negative 44x equals 88. We know that is true because we simplified, right? Okay. I'm going to actually show that other step a little bit clearer that we did before. I'm going to go ahead and do the division. And I'm going to write down that That is the division property. Can I put div for divide or division? You can put sub for subtraction. Well, actually, we've got to be real careful on subtraction. I think we need to put more than that because sub could be substitution property as well. Okay, so let's do the division property of equality. You could put mults for multiplication. I'm okay with that. And then let's go ahead and finish it up by simplifying and saying that x must be -2. Okay, and we know that that is true because we simplified. All right, there you go, guys. We did 2 algebraic proofs. Make sure you got good notes. We're going to do lots of proofs, and we're going to continue our discussion about the properties, postulates, and all that stuff. And we're going to keep loading up our suitcase so that we have lots of reasons for making statements. Let's go back and finish this 2-column proof off with what we have on the top, which is our statements and our reasons. All right, I'll see you guys in class tomorrow.